Good afternoon, everybody, and welcome to UNDP's third Build Smarter video webinar. We are just going to wait about 2 more minutes to get some more people. I see we've already got a good number of attendees joining, but just want to give a couple more minutes. Good evening, everybody. I'm Ajwal Pinder, and I'm the Recovery Coordinator for the United Nations Development Program here in the Bahamas. Just to start you all off with some background information in case there's anybody new who was not present in webinar number 1 and 2. UNDP has been working in many areas since Dorian impacted Grand Bahama and the Abacos. One of the most harsh realities of Dorian was the destruction of such a large proportion of our buildings. During assessments made post-hurricane, it became clear that the homes which had been built to code largely fared well, but that a large proportion had not been built to our current national standards. The Bahamas does have one of the most progressive building codes in the region, but Dorian showed that there is a need to better assist individuals in how to meet those standards, which was what led to the Ministry of Public Works creating their very, very useful guide to housing standards for the Bahamas, which you'll be able to download. I'll put the link in here in the chat for you. It's a really easy to follow guide to the building code of the Bahamas, and it will help all homeowners and your contractors and subcontractors in building hurricane resilient homes. As part of that work, right now we have one of our fellow Bahamians, Nick Sims, that has been hired to lead our Technical Assistance Center in Abaco in conjunction with the DRA's Small Home Repair Program and Rotary Clubs of the Bahamas. COVID, as we all know, unfortunately has impacted so many things, including our ability to conduct the same sort of hands-on activities as we had hoped to. So as a result, we are doing this Build Smarter webinar series where you'll be able to hear from him, ask him questions about your rebuild project. So just as if he was right there in Marsh Harbor or Foxtown or Elbow Key, wherever you are, or if you're over in Grand Bahama from out in the east or in Freeport, ask away. As way of introduction, Nick Sims is a licensed professional structural engineer with 26 years experience in the Bahamas and 17 years in particular for Abaco. Also provide you with some information on how this evening session will work, Nick is going to begin with a presentation on key points related to masonry wall construction. And then at any point during the presentation where you would like to ask a question, you can virtually raise your hand. You'll see the icon to do that. It looks like a raised palm. Just click on that and I can unmute you so you can talk to Nick directly, or you can type your question into the question and answer area of the screen where it says Q&A. If you're watching on Facebook, please also feel free to write your questions there and I will share them with Nick. Finally, just as we get towards the end of the session, I'm going to have a poll for you, so please do participate in that. We always love your feedback. And Nick, I am going to let you take it away.
Good afternoon again, all. Welcome once again to the Build Smarter webinar series. Thank you for finding the time to take part in this training series. Again, this is something probably best done face-to-face with an audience, but the circumstances simply don't allow it at this time. So to reiterate, the intent of this training series is to provide an easy-to-follow, condensed presentation of the requirements of the Bahamas Building Code, the guidelines in the Build Back Better manual, as well as best building practices to help builders as well as homeowners in Abaco and Grand Bahama rebuild their homes so they are hurricane resilient. The Build Back Better manual was developed post-Dorian and is a Ministry of Works document drawn from the Bahamas Building Code and developed in collaboration with the United Nations Development Program in Jamaica, the University of the Bahamas, and the Disaster Reconstruction Authority. It is hoped that from this training, builders will have some key steps in the building process reinforced for them and perhaps learn some new things that improve their practice. Likewise, it is hoped that homeowners will become familiar with the key steps of the building process so they are more informed and aware of what is likely a very important and the largest investment of their lives. And so thus allied as a team with the builders in achieving homes that are hurricane resilient. This training this afternoon is the third of several, as Etoile mentioned, and is focused on the construction of single-story homes in the Bahamas. And we will be looking today at masonry wall construction. Next slide, please. So just a quick run through of the agenda this evening. I'll present the materials that are associated with masonry wall construction. I'll run through the two prescriptive methods drawn from the Bahamas Building Code that outline masonry wall construction, and then we'll have a question and answer period following that. So today we are presenting the two prescriptive methods for construction of masonry walls for simple single-story homes. We will be outlining the main steps as well as quality checks along the way. These walls are to be a nominal 8 inches thick, corresponding with the typical 8-inch thick concrete blocks that are available locally. While it is always best to include a professional architect and engineer in the design as well as quality control checks during construction of your home, these methods will produce suitably hurricane resilient walls for the majority of single-story homes. There are two prescriptive methods for building masonry walls in the Bahamas. The first is the confined, unreinforced cement masonry block walls within a framework of reinforced concrete columns and beams. Walls of this method are limited to a maximum spacing of 20 feet between columns, as well as a maximum area of 240 square feet of block wall panel between the reinforced concrete frame of columns and beam that fit around the frame. The second method is reinforced cement masonry block walls capped with a reinforced concrete beam. As a reminder, in both instances, the walls are being built off of the typical reinforced concrete slab on grade with masonry foundation walls and reinforced concrete footings as covered in our first training session. For those areas where there is high risk of significant flooding during a storm, please consult a design professional for guidance and advice. An important point to be aware of with flooding is that reinforced concrete block structures perform better than unreinforced concrete blockwork walls within a frame of tie columns and tie beams. And this was the case as well in Dorian. Next slide, please. So we'll begin with materials and start with the cement blocks. The typical cement block used locally is made of Portland cement, sand, and aggregate. Only cement blocks that are approved by the building control officer at the Ministry of Public Works and that are manufactured by plants approved by the building control officer are acceptable for use. The approvals for these blocks last for 12 months maximum typically, after which the blocks and the plants must go through the approval process again. So it's an ongoing process to ensure that blocks are being produced that are high quality. Ask for a copy of the building control officer's approval from the vendor when you purchase your blocks. Do not purchase blocks from a vendor that is unable to provide proof of approvals. And you see that, go back one sec. So you see there, the diagram just shows a typical block. I'm sure most of us are familiar with it. And it's called an 8-inch block because it's 8 inches thick. It's also 8 inches tall and 16 inches long. Okay, next slide, please. Okay, so we're just going to talk about the cement for a little bit. The cement for mixing the mortar, for bonding the cement blocks together in building the foundation stem walls and the main superstructure walls, which is what we're talking about tonight, must be type M or S and conform to the standards of ASTM C270. ASTM stands for the American Society of Testing and Materials, and it's just it establishes protocols for ensuring quality of materials. So you can see those are two just photos of bags of cement. One is type M, one is type S. So when you purchase a masonry cement, you want to make sure it's either one of these two. And as you can see in the little table there, type M is stronger than type S. Okay, next slide, please. And what we have here is another table that shows the typical applications of these mortar cements for different construction projects. And as you can see there with type M, it's only to be used for below ground, below grade foundations and walls. So that applies to us in the Bahamas. So our foundation walls must be built with type M masonry cement. And then if you can see that you go down a couple lines and you see exterior walls and load bearing walls. This would apply to the walls that we are speaking of tonight. And as you can see, the type of mortar that you can use is M or S. Okay, next slide, please. So concrete is made when cement is mixed with sand and aggregates and water. So the cement for concrete for the columns and the beams is a different type of cement. And Locally, it's we need to use Portland Type 1 or Portland Type 3 cement as specified by ASTM standard C150. And Type 3 cures faster than Type 1, so that will help you determine sometimes you and your builder which type to use. And again, those are two photos that show Type 3. On the buy, you can see there Type 3 and a Type 1. So make sure you look for those when you purchase your Portland cement. Okay, next slide, please. Also in the concrete is aggregate and sand, and they need to be well graded and washed and free of any salts or any other foreign materials. The water as well needs to be fresh and free of any salts. The salts, you do not want this in your concrete mix because we have reinforced concrete, and the salts will attack the reinforcing steel and corrode it and destroy the integrity of your reinforced concrete structure. Next slide, please. So we also install a timber plate at the top of our masonry walls because that is what the roof trusses bear upon. So the wall plate must be pressure treated to guard against termites. The code requires that any standard frame and lumber is rated number 2, grade southern yellow pine or better. The grade, for example, number 2 refers to the strength rating of the lumber. And fortunately for us, the vast majority of framing lumber imported by local hardware stores is pressure treated southern yellow pine. So by default, the builder and homeowner ends up purchasing the correct lumber suitable for framing in the Bahamas and as per our building code. And you can see there in the photo, that's what a typical stamp on a piece of pressure treated lumber looks like. That SYP that you see on the bottom line there stands for Southern Yellow Pine. And this is a number 1 grade Southern Yellow Pine, so it's actually stronger than number 2. Next slide, please. So with concrete, it needs to be reinforced, and we use reinforcing steel bars for that. Steel reinforcing defoam bars, excuse me, for concrete must abide by the standard ASTM A615 and B grade 60. It is recommended that reinforcing steel is also treated for corrosion protection. Commonly used options include epoxy-coated steel bars or hot-dip galvanized steel bars. Typical size steel reinforcement used for single-story masonry Bahamian homes include number 3s and number 5s. The larger the number, the bigger the diameter of the reinforcing bar. Do not be shy to request the certification paperwork for the steel reinforcement before you purchase it. This ensures the reinforcement has met the standards for fabrication and quality control at the plant. Next slide, please. So the photos on the left there show you some bundles of steel rebar. The top photo shows untreated steel, typically called black steel. And the middle photo is epoxy coated steel. That's the green. So that's basically like a really tough paint that goes over the steel rebar. And then the bottom photo shows hot dip galvanized. To your right is a diagram of various identifying marks that you can find that will exist on steel rebars, so that you can identify the steel and know what you're buying. And it also kind of highlights the fact that the steel rebars are ribbed. You notice there's a little tick there that says grade mark and it points to 60. That refers to the yield, what's called the yield strength of the steel. Very important. So you want to ensure that you get the correct grade steel for your home. Next slide, please. So when you're pouring reinforced concrete, you're going to need to fabricate some formwork to shape the concrete while it cures. And for this purpose, utility grade lumber and plywood is acceptable. It has no requirement to be pressure treated. So you can save some money there. Pressure treated wood costs more. Next slide, please. So we need bolts to hold down that timber plate at the top of the masonry wall. And you want to use only what's called A325 grade hot dip galvanized bolts, nuts and washers. Or if you can afford to, it's best to use stainless steel grade 316 bolts, nuts, and washers. This ensures suitable protection against the always present conditions for corrosion on small islands, as well as these are the specified types of materials that are compatible with the chemicals and metals used in the process of manufacturing pressure-treated lumber, such that there are no adverse reactions that would occur. If you don't use the correct material bolts, the chemicals in the pressure-treated lumber will attack the bolts and degrade them over time. Next slide, please. So we're gonna, that completes the material portion of our presentation, and we're gonna go to prescriptive method 1 now, which is the tie beam and column reinforced frame with infill masonry walls. Next slide, please. So this prescriptive method is the more common method of the two, and involves building the masonry walls first, then fabricating, forming, and pouring the tie columns and block cells around the wall, around wall openings, then fabricating, pouring, forming, and pouring the tie beam. Reinforced concrete columns must be at each corner of exterior walls at intervals not exceeding 20 feet center on center, and adjacent to any wall opening exceeding 8 feet in width, as well as any corner opening exceeding 4 feet in width, and at the end of freestanding walls exceeding 2 feet in length. Next slide, please. So it's just a little diagram that kind of highlights some of the things I was just talking about. So you can see the columns and the beams are being pointed out. You can see columns are being shown at the corners and adjacent to openings, door openings, window openings. For this particular diagram, it specifies a tie column spacing of 15 feet, but that's for high seismic zones. So that really does not apply to us. So our maximum spacing is 20 feet. Next slide, please. And this is another diagram that, again, just highlights some of the stuff that we're talking about. And as you can, the darker gray areas represent poured reinforced concrete columns. Those are the vertical gray areas, and the horizontal gray at the top is the tie beam. The horizontal midline gray is the concrete slab on grade, and the bottom horizontal gray is represents the concrete footing. You can also see the reinforcement of the beam extends down over the top of those the window and the door openings, and you can also see a vertical dark line in the block cells. That represents reinforcement of the block cells vertically around the opening. So all openings end up being reinforced as well. Next slide, please. Almost all plans in the Bahamas will, for reinforced concrete homes, will have on it a column schedule. So this is just a typical column schedule, and it provides a detail to the builder on how to fabricate the columns that are necessary for their home. Next slide, please. And this is just a a little bit more detail on cross sections of typical columns that are used in Bahamian homes. And it, again, it provides information to the builder on how to go ahead and fabricate the steel cages for those columns, as well as the size requirements for the columns. You notice that each of those columns has a note that calls out 1.5 concrete cover. And what that refers to is the steel reinforcement within has a concrete cover of 1.5 inches thick. This protects the steel from the outside elements and provides corrosion protection. Next slide, please. These are just cross sections of walls that show how the components come together. So you see at the bottom there's a footing supporting a foundation stem wall, then a concrete slab on grade, upon which is laid the walls of your home, and that is then capped with a tie beam. And on top of the tie beam is a timber plate. You can see a close-up there on the diagram on the right, and it's to that timber plate that the truss bears upon, the roof trusses. Next slide, please. So we're just going to run through the process of for prescriptive method 1. You want to set story poles at the corners. The story pole is that vertical wood member that you see right there, nailed off to the foundation stem wall and extending up. When it's set, you want to ensure that the poles are plumb and check square on the poles. Square refers to the correct layout of the building per the plans, so that the dimensions are so that the home is being built as per the dimensions on the plans. Then you want to organize your block row layout on the story poles and pull your block laying guideline strings. It might not be too clear in that photo there, but you can see to the left of the vertical pole towards the bottom, you see some 3 or 4 strings going off towards the left. Those are lines to assist the mason with laying the block plumbing level. You also, then you want to lay out the window and door locations by marking them where they're going to occur, making marks on the concrete slab. Then you want to figure out your sequence plan for laying your block walls. Go ahead and distribute the blocks on the ground floor slab where they need to be. And from the where the window and door locations are located on the slab, you can then go ahead and install any vertical steel to each side of each planned window and door opening that is less than 8 feet in width. And you can do that by either lap splicing to vertical steel that's coming up from the foundation level that is extended past the slab. And this is if you've done a lot of planning from the foundation level and figured out where your window and door openings are going to be, even when you were building your footings. Or you're going to drill into the slab and fix it in place using epoxy grout. This vertical steel then extends and hooks eventually into the poured concrete tie beam that caps the wall. Next slide, please. Next slide, please, sorry. And this is that diagram again that we saw a little bit earlier, and it just highlights again what we've been talking about. You have footing at the bottom, foundation stem wall upon the footing, then a concrete slab poured upon that, then blocks laid upon that, and those blocks of your house wall are encased within a framework of reinforced concrete columns and beams. And the openings are reinforced on either side as well. Next slide, please. So you continuing with the process, you want to just go ahead and lay your block walls. it's important to get the mortar mix correct, and the mortar mix is 1 part cement to 3 parts clean, well-graded sand. And again, there's a standard that applies here, and that sand must comply with ASTM C270. The mortar joint should be 1/2 inch to 5/8 inches wide, and you want to continually check each run of block work as it's laid up for plumb and level. Next slide, please. Then you want to, concurrently, you want to be fabricating your steel rebar cages for your columns. And again, here's details that on the left there of typical columns in masonry homes, with information that the builder would need to fabricate the steel cages that would be within the reinforced concrete column. And the diagrams on the right sort of give you an isometric view of the cages and how they situate within the column. And as you can see, you can make out that there is concrete cover to the steel, which is very important, again, to protect it from corrosion. Next slide, please. Okay, continuing on with the process, you want to lap splice your vertical steel rebar of the column cages onto the vertical steel of the columns that are coming from the foundation level, and that steel that extends past the top of the slab on grade. Those lap splices must be a minimum of 18 inches long. Once you've got this done, you want to form up your columns and ensure as you go with your formwork that the steel is located within the formwork so that it achieves that concrete cover of 1.5 inches, which protects it from corrosion. Leave out one side of your formwork so the column can be inspected by the Ministry of Public Works. Then you want to go ahead and organize your inspection of your column steel with the ministry, and make sure you secure a copy of that inspection certificate for your personal records. Then you'll complete the formwork for the columns, and then you will pour the columns, as well as any block cell voids adjacent to the openings where you've installed that piece of vertical steel. Okay, next slide, please. If you are hand mixing concrete, you must take care to use the correctly proportioned mix ratio to ensure that the concrete design strength is achieved. To achieve, typically concrete columns and beams must be at least 3,000 PSI. So to achieve this, the Build Back Better manual stipulates the concrete mix be 1 part cement to 2 parts sand to 4 parts aggregate. And when those parts are measured in cubic feet, the mix in water is limited to 6 gallons. Use a wire brush to remove any concrete that may be coating the exposed end lengths of any column steel rebars to ensure proper bonding to the new stage of concrete pour for the beams. It's very important to do. If you don't do that, you will not get good bonding of the concrete to the steel, and that is a critical component of reinforced concrete design. Next slide, please. Okay, then you want to move on. After you've poured your columns, you want to go ahead and now fabricate and install your tie beam steel rebar cage, as well as the lintel cages that go above the window and door openings. And there you see a few diagrams, very similar to the diagrams for the concrete columns. This is information that the builder would use for fabricating tie beam rebar cages, as well as there's those 2 diagrams at the bottom of that show the builder 2 options for how to splice tie beam main steel. And there's two methods shown there. It's very important that splices are done correctly so that you get the proper length splice as well as you maintain concrete cover to the tie beam steel. Next slide, please. Once you've got your tie beam cages in place on top of your wall, you want to go ahead and install 90-degree minimum length 18 inches hook splices that connect the column steel to the beam steel. And then there is an additional reinforcement needed at the corners of the tie beams to ensure continuity of the steel. And those two diagrams on the right sort of reflect that. That's meant to show the splicing that occurs at outside corners of tie beam steel. And there's two methods to do it there, and both are shown, and the two minimum splice lengths that are required. Next slide, please. Okay, so still with the process of prescriptive method 1, you're going to go ahead and install pans in the open cells of the cement blocks at the top of the wall. So what this does is it prevents loss of any concrete from an unnecessary filling of those open cells of the blocks. That's at the top of the block wall. So if you don't do that, you're going to waste a lot of money filling up block wall cells that don't need to be filled up. Then you want to form up one side of your tie beam and lintels, and set your roof plate anchor bolts in the top of the tie beam formwork. And that photo there sort of shows what's going on. You got formwork on the bottom, and on one side of the tie beam, you can see the rebar cage of the tie beam, and you see at regular intervals, you see a piece of timber that's nailed to the top of the tie beam form, and that is what's going to where the bolt that's going to hold the bolt in place while the tie beam is formed. And that's why they're spaced regularly, because the bolts for the wall plate are also spaced regularly, 30 inches on center. Okay, next slide, please. And this is, again, sort of just a close-up of that, more detail that kind of shows what I'm talking about. Formwork on the bottom and one side. You see a vertical column coming up, and there's the horizontal rebar cage within the formwork of the beam, and you see the beam rebar cage going through the column rebar cage. Next slide, please. Okay, so once you've got that done, you want to go ahead and organize the inspections of the tie beam steel works, and again, secure a copy of the inspection certificate for your personal records, and organize the pour, and make sure to install any bulkhead formworks if the tie beam pour cannot be continuous. And if this is necessary, please seek a professional engineer to advise you where to locate the bulkhead for your particular design of your home. Once you've got all this done, you can just go ahead and proceed and pour your tie beams and lintels. You have to let that concrete cure for a certain amount of time. If you use type 3 cement, you can let it cure for 3 days. If you use type 1, it must cure for 7 days. Once that curing is done, then you can strip the formwork and proceed with construction of your roof. Okay, next slide, please. Okay, so we're gonna talk about prescriptive method 2 now, which is just reinforced concrete block walls that are capped with a tie beam, a reinforced concrete tie beam. Next slide.
I think, Nick, just
Hi.
before we move to prescriptive method 2,
Right.
I wanted to just check in with the audience. I know early Brendan Watson had raised their hand. I wasn't sure if you wanted to ask a question, but I think maybe that was well, at least for me, let's just say that was a lot to take in. So I just want to see if folks are interested in asking some questions. Feel free to write into the chat. And yes, Scott Sawyer, I will put in the link here to the manual. But does anybody have a question about the prescriptive method once? Brendan, feel free to talk. Mr. Watson, are you there? Just checking. Nope. Okay. Does anybody else have a question about prescriptive method 1? Or Mr. Bruno, I see you're present. Do you have any comments about it? If not, we will move on to the second section. Okay, we're going to move on then, Nick. And while he is doing that, I'm going to put in the link. I'm going to put in the link for 2 things into our chat. One is going to be to actually download the Build Back Better manual. And then the second is just going to be the link to the Facebook page for UNDP. Just so you know, if you either have to leave early or if you've come in late, the video will be available there for viewing afterwards. So please feel free to go and rewatch this after it is done if there's a bit you wanted to come back to.
Okay, are we good? Okay, next slide, please. Okay, so again, we're going to discuss prescriptive method 2 now, reinforced concrete block walls that are capped with a reinforced concrete beam. This is the second prevalent method and is used when tie columns are not used. The 8-inch thick concrete blocks are laid and filled with concrete 3 courses at a time. What that means is you lay down 3 rows of block, you fill those block cells before you continue laying block upon that. So you never get too far along before you fill those block cells. This ensures that the cells are filled correctly and the concrete maintains its integrity as you fill the cells. The blocks are to have number 5 rebars located 32 inches on center. And at each corner, there need to be 3 number 5s in the block cells. And they run continuously from the footing of the foundation through the walls and into the tie beam above. So if you can imagine it as a series of smaller columns that are much closer to each other, 32 inches apart, as opposed to prescriptive method 1, where you have these much more robust, larger tie columns that can be 20 feet apart maximum. So that is the difference. Any lap splices in the reinforcement, again, must be at least 18 inches long, again, similar to the reinforced concrete columns. In every second course of block as well, we want to install horizontal reinforcement in the mortar bed between the courses. So this is an additional reinforcement, horizontal reinforcement that gets installed in reinforced block work. This reinforcement can be 2 number 3 rebars or a ladder, what's called a ladder type reinforcement. Next slide, please. And this is a diagram that sort of highlights what I've just been talking about. So you can see the rows of blocks are getting laid. And just a note how those blocks are getting laid so that no vertical joint of any block lines up with a block below, any vertical joint of a block below it or above it. So all the vertical joints are always staggered. It's the same way you install plywood on a wall or a roof. It makes the wall stronger. And you can see shown, called out vertical reinforcement that goes inside the hollow cells of the blocks. You can see the mortar bed being shown. between the rows of blocks as well as between each block in a row. And you can see it's called, they're calling out mesh or other grout reinforcement there, which is the horizontal reinforcement that gets installed in reinforced concrete block walls. And then wherever there's the vertical reinforcement, you're going to go ahead and fill those block cells with concrete. So every 32 inches, you're going to have a mini column inside of your reinforced concrete block wall. Next slide, please. The diagram on the left and the photo on the right highlight that horizontal block wall reinforcement that I was speaking of as well. So just another indication of how that sort of works and fits together. Next slide, please. Okay, so we're just going to run through the process of prescriptive method 2. And again, you want to ensure your story poles are plumb, and you want to check square, organize your block row layout, pull your block laying guideline strings, locate your window and door openings on your concrete slab, establish your sequence, and distribute your blocks on your ground slab. Next slide, please. Next slide, please. Thank you. Then you want to go ahead and install your vertical steel wherever your planned window and door openings are. Again, very similar to prescriptive method 1. And you're either going to lap it to steel coming from the foundation, or you're going to drill that steel into the slab and fix it in place with epoxy grout. And this is that diagram on the right just highlights that steel that occurs there around that window opening. Next slide, please. Then you're going to go ahead and lay your block walls. And again, the mortar mix is 1 part cement to 3 parts clean, well-graded sand. The mortar joints are the same. It should be a 1/2 inch to 5/8 wide. Continually check, plumb, and level as you lay up the block walls. Every 3rd course of block that is laid is filled with concrete where the reinforcement is before proceeding with any additional courses. Prior to filling with the concrete, check plumb and level of walls, as well as overall building squareness with every 3rd course. And it's just to make sure you stay on track and you can make adjustments as you go along to correct if you are getting off track a little bit. And using this method, you just build the walls up to the height of the bottom of the tie beam. Next slide, please. So then you install 90-degree hook splices that are a minimum of 18 inches long that tie that vertical steel in the block walls to the tie beam steel. Then go ahead and install the additional reinforcement to the tie beams at all wall corners to ensure continuity of the steel. You form up the tie beam and the lintels, check plumb and level and overall building squareness. Set your roof wall plate anchor bolts in top of the tie beam formwork. Organize the inspection. Secure a copy of the inspection certificate. Next slide, please. Organize the pour. This is simply reiteration of the same process now from prescriptive method 1. Put bulk work in the tie beam. Where if the pour cannot be continuous, seek the guidance of a professional engineer in that instance. Go ahead and pour your tie beams and lintels, let cure for the specified number of days, and then you strip all your formwork and you can proceed with the rest of your construction, including loading that block work and tie beam and tie columns with your roof framing. And that concludes prescriptive method 2. So we move on now to any questions and answers. Any questions? Hopefully I have the answers.
That is definitely what we hope. So please, again, everybody, either if you want to verbally ask your question, and please feel free, you can talk about your home site that you're rebuilding on or your plans for rebuild, anything that's going on. You can either raise your hand with the little palm sign next to your name, and I can then unmute you, or you can type it in either to the question in answer part of the area here or into the chat. And I'm going to check the Facebook and YouTube as well, Nick. Okay, so there's a question about if you have a recommendation or what the difference is between the epoxy versus hot dipped for the steel.
Right. Good question. I prefer hot dip galvanized because the epoxy tends to get a little bit more damaged on site as you're going through the fabrication method, fabrication of the cages, and just handling it and getting it into place. And so when that epoxy gets chipped, that exposes the steel to corrosion at that point. So you have to take a lot of care. I feel you have to take more care with the epoxy to ensure the integrity of the corrosion protection, which was the whole point of it to begin with. So there's more care, more attention, more work involved in the epoxy, in my opinion, versus the hot dip galvanized. So for that reason, I prefer hot dip galvanized over the epoxy steel.
Okay, thank you. I'm sure the Facebook folks will appreciate that. Looking to see if anybody else is, again, I did have Brendan Watson had their hand up earlier, but maybe that's being lowered. Anybody else? Another question? So then I'm going to ask you a question because I'm always fascinated by this length of curing time. So this difference between the type 3 being a much quicker curing time than the other one, does that mean that it's that much more expensive? Or why would I not go with the quicker curing time out of interest?
It probably is, there is a cost difference.
Okay.
It's a different fabrication process at the concrete plant that achieves that quicker curing. But in the big scheme of things, it's a call you have to make on site. The homeowner has to make with their builder.
Right.
There could be instances where they need to get on with construction as quick as possible, and that also has cost implications.
Yeah.
So those are conversations that the builder and the homeowner need to work through as they build their homes.
Okay, got it. And yes, time can often be money, so
Right.
that is there. Okay, so everybody, I am going to ask just a quick poll here for you. We're just really interested in knowing if these materials, the information that you got out of this webinar, if it was helpful to you in your rebuild process. It's important for us because then we can go back and tweak things. So please do let us know if it helped you at all. Ooh, okay. And then I don't know, Nick, if you can see there, but John has asked a question saying, when tying into the belt, do you have angle top of column to tie in? Can you see the question there?
When tying into the belt, do you have? I don't understand the question.
John, I think we're missing something. It's like, do you have to angle the top of the column to tie it in? Is that the question? Here, John, I'm going to allow you to talk if I can get my mouse back.
Yeah, good night. I was just asking, when you tie it into the belt, I know the steel has to go past the beam. So when you tie it into that steel on the top, you just angle the steel, bend it, and then tie in with tie wire.
No, I understand. Yeah. So when you say angle, you mean hook? Are you?
Yes.
Right. So you want to use a 90-degree hook to to tie your column steel into your belt steel. Yeah.
Okay. So, and then how long should that angle be on the top? Or
18,
in either direction?
18 inches minimum.
Okay. Thank you.
Yeah. Okay.
Thanks so much, John. That was definitely a good technical question. Does anybody else have any other questions? Again, please feel free to either use the chat or the question and answer box like John did. John, I'm going to mute you unless you have another question.
No, thank you.
Thanks, John.
Okay, if this is the last call, again, you guys can ask him anything about your site. And if not, though, I did put in, everybody, the link is here in the chat. If you are interested in downloading the wonderful manual that the Ministry of Public Works did in conjunction with the DRA and University of the Bahamas, Engineers Without Borders, and UNDP. And I'm also just showing you here on the screen, you can see the Facebook page. So if you do have any questions that you want to come back to, please feel free. The video will be up on the Facebook page. There is also a YouTube channel where the previous videos are available. And finally, if you do have any specific questions that you want to send, or you even have a photo of your construction site and you'd like to get Nick's opinion on something for it, you can email us directly. I've put my email in there. It's just the etoile.pinder@undp.org. Etoile being etoile.pinder@undp.org. But I think we have one more question has come in. Okay, so Mr. Ambrose, you said where can the booklet be downloaded? I don't know if you can see here in the chat. There's a chat box, but if not, I'm gonna put it into you directly. I think I can do that. I popped it in there in the response to your question, and I'm also putting it directly in the chat to you. So thank you, everybody, for participating. Unless anybody else has another question, I think that was really impressive. You guys have hung out for an hour talking about this, so it's great. Nick, as always, thank you so much for your time and your insights. Thank you to everybody who participated, and please do remember just to tune into the UNDP Jamaica Multi-Country Office Facebook page. We will be doing more sessions in the new year, so stay tuned for those, in particular on roofing and some other things. So thank you very much, everybody, and have a good night.
Good night.
Oh, wait, Nick, don't go.
Oh.
Oh, no. Mr. Ambrose just said thank you. I saw it as a question. That was all. Okay, perfect. Thank you, everybody.
Okay. Good night.